Okay, turn to page 504, and we're going to continue discussing the use of the scientific method. So we're going to call this part 2. So in your book, turn to page 504 and let's begin. In step 2 at the top of page 504, it reads taking samples. In step 2 of the scientific method, scientists collect data. In the early example, in which scientists were studying pond water, they sampled the water. In the practice passage on the previous page, researchers collected samples of bacteria from nasopores to study acne. A sample is a portion of the entire thing or population that is being studied. It is usually impractical or even unethical to study, for example, all the water in a pond or every bacterium in every nasopore of every teenager in the world. This is why scientists take samples. Let's look at the next paragraph. To be able to make valid inferences about the entire population on the basis of data from samples, scientists must follow certain guidelines. A major concern is that the sample taken may not be representative of the entire population. This is, the sample may differ from the population in an important way. An unrepresentative sample introduces bias into the results of the study. Next paragraph. One way to prevent bias is to select a large enough sample size to reduce the probability that, by random chance, the sample differs significantly from the population. So let's take a look at this question. Think about the scientists who are studying bacteria in pond water. Which of the following sample sizes is more likely to lead to valid inferences about the pond's water? And if you look at the choices they're giving you, 1 and 2. And 1 reads, 1 sample from near the spring that supplies the pond with water. 2, 10 samples from various places in the pond. So what is the question asking you? Which one would more than likely lead to a valid inferences about the pond's water? And of course in your book they tell you 2. The correct answer is statement 2. And they give you an explanation why. If the scientist studying pond water took just 1 sample of water, that sample might happen to contain only a few bacteria, and the scientist would conclude incorrectly that the entire pond has a low concentration of bacteria. So that's why you're taking many samples. Now let's look at the next paragraph. It reads, furthermore, scientists use randomization to increase the chance of valid results. Randomization is used to assign samples to experimental conditions. If, for example, the scientists conduct an experiment to find out whether pond bacteria grow more in the presence of phosphates, such as those found in farm runoff, they would begin by taking samples of pond water. Then they would randomly assign half the samples of pond water to a control group which would not receive any treatment. They would assign the other half to an experimental group to which they would add phosphates. Then the researchers would measure bacterial growth in both groups and determine statistically whether there was a difference. Sometimes it is impractical. Look at the bottom of page 504. Last paragraph. Sometimes it is impractical or unethical to select a sample from the population at random and then subject part of that sample to a treatment. So let's look at this question at the bottom of page 504. Suppose that the researchers above wanted to study whether greater amounts of farm runoff correlates with fewer fish in ponds. What should they do? 1. Identify a random sample of 50 ponds. Order the farmers near half the ponds to limit chemical runoff. And order the farmers near the other ponds to increase runoff. I hope you're following along. Look at the top of page 505 so we can finish up. 2. Identify a random sample of 25 ponds where there is a high level of chemical runoff from farms, and identify another random sample of 25 ponds where there is a low level of farm runoff. So what is the question asking you? What if the researchers want to study whether greater amounts of farm runoff correlates with fewer fish in ponds? So either 1 or 2, and then you can see here in your book, top of page 5, the correct answer is 2. The researchers could not force some farmers to create more runoff in order to make a treatment group of ponds. For one thing, the farmers would likely not want to change their agricultural practices. In addition, potentially doing environmental damage would be unethical. Working with the samples in statement 2, the researchers would observe the numbers of the fish per volume of water and compare the two groups. This type of study, in which the scientist does not manipulate conditions, is called an observational study. A risk is that the samples differ from each other in a relevant way. Besides, the variable being studied, that affects the results. For example, the ponds with low farm runoff might also happen to be in an area with geology that gives the water a different pH, resulting in different fish populations for a reason that has nothing to do with agriculture chemicals. That'll end page 504. Use the scientific method, part 2. We'll stop here.